Daniel Spoonhower, or I will call you Spoons, okay? I think it's easier to pronounce. So Spoons is a co-founder and chief architect at Lightstep, where he's building next-generation monitoring and observability tools. He is an author of Distributed Tracing in Practice. Previously, Spoons spent almost 6 years at Google, where he worked as part of Google's infrastructure and cloud platform teams. He has published papers on the performance of parallel programs, garbage collection, and real-time programming. He has a PhD in programming languages from Carnegie Mellon University, but still hasn't found one he loves. At the end of this talk, you will have a better sense of the value of tools that you already have and some ideas as to when you should consider expanding your toolbox. So please welcome on the red stage of Craft 2021, our last presenter for today, Spoons. Spoons, the stage is yours.
Thanks for the introduction. My legal name, yeah, it's Daniel Spoonhower. I've worked with a lot of Dans though, so my friends, my coworkers, my 5-year-old sometimes all call me Spoons. I live in San Francisco. I used to do programming language research and research in language semantics. I carried a pager for many years. I've worked in a lot of different systems and software systems. I wrote a book, and I'm a co-founder at Lightstep. But maybe more importantly, who are you? I'm assuming you all are software developers of some kind. You sit in front of a laptop and type. And if you're the kind of software developer that works on software that comes in a box and is wrapped in plastic, maybe I have a little bit less to offer you today. Although thanks for if you're some of the folks that worked on HyperCard. HyperCard was the thing I grew up on. No, maybe you're thinking a little bit about a change. Maybe you're thinking about a career in site reliability engineering, or maybe you already are a site reliability engineer, or you work on a software system that is part of a service that's provided to users. Or maybe you've heard this word DevOps, or maybe you are a DevOps engineer. Maybe someone in your organization is a DevOps engineer. Maybe you just want to pretend that you're a DevOps engineer at parties or something like that. DevOps is a thing that folks talk about lately, and I think is sort of an important part of the context for what I want to talk about today. So what is DevOps? Okay, I'm going to try to offend everyone now by giving a bunch of definitions of DevOps. Hopefully you'll like one of them, and maybe you'll hate 2 or 3 of them. Or maybe I've offended you by assuming that you know what DevOps is. If you don't, then here's a bunch of definitions to choose from. So maybe first is it an approach to operations that uses software engineering? If you're familiar with the phrase cattle, not pets, as a way of thinking about servers, I think that falls into this definition. A lot of Google's SRE practices fit in here, as well as things like infrastructure as code or GitOps. But maybe you're thinking, no. DevOps. It's a work culture that's focused on trust and collaboration. This is where we have things like blameless postmortems. And if we're gonna do DevOps, if we're gonna have developers, participating and responsible for operations, we can't rely on the old way of doing things. We really have to build empathy for other people in our organization. But maybe you're thinking, no. I know what DevOps is. It's just new tools. I got DevOps already. I've got my CI/CD tool. I've got containers. I've got my orchestration tool. I know how to do DevOps. It's fine. I don't need your help. Maybe you are a DevOps engineer, like I mentioned, or maybe there's a DevOps engineer in your organization. And DevOps is not about tools or approaches or anything like that. It's just a new job. No big deal. Or maybe it's a process for measuring that operations work that we didn't have or we didn't need before, right? And this might be something like value stream management, right? And these are all, I think, actually totally fine definitions. And in my job, I'd have to talk to people that think about all of them this way. But for me, like if I really get to the core of it, the thing that's important about DevOps is that it is a decentralized way of delivering and operating software systems. Right, we're moving away. If we're adopting DevOps, we're moving away from a centralized IT ops organization where there was one team that that was responsible for deploying new systems, that was responsible for infrastructure, that was responsible for any changes to the production environment. And we're moving to a world where that responsibility has been split up and distributed across a lot of different teams. Maybe those are distributed SRE teams, maybe those are all of you in the audience. And I think, this actually kind of explains why we have all these different definitions, right? Because if we are going to decentralize, if we're going to distribute things, like we are going to have to scale in a different way, and software engineering is really good at scaling. If we are going to share responsibility, we do need to trust each other better. We're probably going to need new tools too, because it's a different way of working, and we're going to need people to help us build, adopt, maintain, and understand those tools. And if we're thinking about the efficiency of an organization as a whole, then we're going to need new processes for measuring this as well, right? So all of these things I think are true. I don't think I have a favorite. I like to think about DevOps as really this breaking up of this responsibility into a lot of small pieces. But why would we do that? That sounds hard. Why would we change, right? I think there's really two pieces of it. One is that we want to enable organizations to grow more quickly by scaling operations with the development side. DevOps actually isn't for everyone. I've worked in small organizations where it actually didn't make sense. We had a centralized team, and they were responsible for making changes to production systems. They were responsible for carrying pagers, for responding to incidents. And that was fine for a while until the rate of change of the software became so great that those people were overwhelmed, right? So we had more and more developers. Each of those developers is building new features. They want to push out new code, fix new bugs. But the ops team was just overwhelmed by what was happening. And so we actually had to split that responsibility and share it with the developers. And the other big reason is that we want to accelerate development by decoupling the changes that these teams are making, by decoupling these deployments. That'll mean, that each team can move faster. They don't have to coordinate. They don't have to sit in meetings. They don't have to wait for each other. They can just go and do it. They don't need to check in with anyone else. And hopefully that means you're getting more features to your users faster. Your users are happy. Your business, your organization can grow. Okay, so what does it look like, DevOps in action? So, here's you sitting at your desk. Your posture is not that good, by the way. Gotta relax a little bit. But someone else in your organization is going to push some code out to production, right? So they're just doing their usual, daily, weekly release, whatever it is. At the same time that maybe a lot of other people are making changes, right? And that's fine. Maybe that introduces a new feature. Maybe it changes performance in a small way. But maybe that change in performance actually has impact on other services within the software system. Maybe that's not what those other services are expecting in terms of performance. And maybe those systems are now behaving in a different way that's not what your system expected. And now you're hearing about this change. But no one asked you whether or not this was a good release or not. Maybe it actually is a good release, and maybe there's a good business reason to keep it, but it's still not something that you planned on. And so really part of the issue here is that as we've divided up responsibility, as we've allowed these people to work more independently, we've sort of lost a little bit of touch with the fact that the software itself is still very interdependent, right? All of the pieces of the software are still connected. They still need to talk to each other. They still depend on changes in their behavior, even if we think that the people are going to be able to operate independently. So really, this is the challenge of DevOps, right? Is that we want to be able to release new software. That other person somewhere in your organization wants to be able to move quickly. That's a planned change. And at the same time, we want to be able to respond to incidents, right? So you, in terms of understanding what happened to your service, you want to be able to understand those unplanned changes. And we want to be able to release more often, and at the same time, we want to be able to respond more quickly. And this tension is like kind of I think the place that we should be looking when we're trying to really do DevOps better, because if we can do both of these things at the same time, then I think we've really solved it. But it's tricky, right? Because if you want to make incidents easier to respond to, you could just change your software less, right? But if you change your software less, you're not getting the features out to your users that they want, and you're not getting the benefits that you would get from doing things in a DevOps sort of way. Okay, so I think this is the problem that we're thinking about. So now back to like my title, what is observability? How can it help? And I'm going to talk about monitoring along the way, right? Because you might be thinking, what observability, isn't that just a fancy word for monitoring? Like, isn't that just a word that somebody invented because they felt like they needed a new word for things? I've got my dashboard. I've got observability. It's fine. I know how to run my production systems. And that might be true, but still, I think there's something to it, because people did start talking about and still talk about observability. And I think if you want to understand a little bit, we could go back to the term itself, right? Like if you took a control theory class in university or studied control theory otherwise, you know that observability is actually a pretty well-defined term in that field, right? It means it's a measure of how well the internal states of a system can be inferred from the knowledge of its external outputs. And that's really important in a lot of different cases, in industrial processes, aircraft. The goal in all these cases is to operate those systems in safe and efficient ways, right? And so if you can understand the internal states from the outputs, that's great, because then maybe you can then control it. That's sort of the other half of control theory, the controllability of a system, and continue to operate in a safe way. And it's actually pretty important because you might not be able to directly observe a chemical reaction, right? Like you can measure temperature and pressure and maybe other indicators of what's happening, and you can build a model of what's happening inside the unit, but you can't like physically look inside or know what's happening. So in control theory, observability is part of creating these stable systems, maybe within dynamic environments, right? Where there's external factors as inputs are changing, or the environment, the temperature of the environment or something like that is changing. Observability is how we can create that kind of stability. And in software systems, the environment is also certainly dynamic, right? Infrastructure is constantly changing. Your cloud providers rolling out new features. Maybe they're having issues. Your users are changing their behavior all the time, right? Maybe in predictable ways, if it's day or night, or maybe in unpredictable ways because, maybe you got onto Hacker News or something like that. But I think for me, this definition doesn't help a lot for two different reasons. One is that in software, the system itself is constantly changing. Like we're not talking about like a single chemical process that's governed by the laws of nature, right? We're talking about software. It's like totally ephemeral stuff. We're rolling out new features, we're optimizing, we're fixing bugs. So trying to model the software that we have today based upon the way that it was behaving 2 weeks ago, I think is a total non-starter. And the second thing about this is it doesn't, I don't know. I mean, I admitted I was a programming language researcher, but I still like to build stuff, right? I still want to know like what tool should I use? And this definition doesn't really help me think about how very well. Okay, so you're thinking, oh, no. I know the real definition of observability. I've heard it before. It's the 3 pillars. It's metrics, logs, and traces. And this definition, maybe you can tell I don't like this one that much either. It does help because, it does say a little bit about how, like, these are different kinds of data that we could be collecting, although you might also hear about errors, sort of a 4th pillar maybe, or sometimes alerting. That's also kind of a 4th pillar depending on who you ask. And the issue here with this one is I've seen organizations that have these things, but it's not solving their problems, right? They're not able to release faster. They're not able to respond to incidents more quickly. So just having these things doesn't seem to be enough. But there's something to it, right? Where do these pillars come from, right? Like it actually goes back to a blog post that was written by some folks at Twitter, where they talked about how they did observability at Twitter and how as their software systems grew, how they changed the tooling that they built in order to understand those systems. And that's great. It's like there was a lot of important work that was done. It's awesome that they can share that work. And I think that gets repeated a lot because it's kind of simple, right? People like groups of 3 or maybe 4. And like I said, these are important kinds of data. I'll talk a little bit more about that later. But again, I don't think, as I said, that having these things constitutes really having observability. So when I think about observability, I really start from not the data at the bottom of the stack, kind of, not the raw material, but go away to the other end. What's the value that I'm going to get from observability? And there's 2 parts to that. I think the first part of the value that you can get from observability is that you can monitor your system's health. I'll talk about the second part in a minute, but just to dig in on that, monitoring means measuring that health in some way. It means showing that data to users, whether that's an operator or a developer or an SRE or whoever. It means notifying those folks when something changes or when you hit some threshold. And it means that you hopefully have some way of talking about goals and reporting. And I'll talk a little bit more about some specific examples of health, but generally by health, I mean just like, is the software or is the system doing what it's supposed to do or what it's expected to do? Okay, so let's talk about some examples. Here's a monitoring system I think that most of you are probably familiar with. We've got a health gauge here. When we get down in the red, that's unhealthy. We've got some notification system here that's probably also going to tell me when parts of the system are unhealthy or where we're in a state that's maybe not good, like there's a door that's open and the car's moving. And we've got some reporting mechanisms here as well. So like this is the full monitoring thing, and the reason these things are built into vehicles in one way or another, right, is that as an operator of the vehicle, this is information you need to know in order to operate. Dashboard, by the way, is a super weird word in English. I looked up where it comes from. It actually didn't have anything to do with instrument panels or gauges or anything like that. It was just this board that was like in the front of the vehicle that protected the driver from mud, from getting dashed with mud. But anyways, also, I guess, a convenient place to put gauges. So there you are. This is also a dashboard, a little bit more complicated. This is the monitoring and control panel from a nuclear reactor. And the nuclear power plants, I think, are super interesting, not only from thinking about monitoring, but a whole bunch of other parts of how we operate systems. These folks have thought a lot about incident response, about how to think about accidents and changes within those systems. So I think there's a ton to learn from that. But again, thinking about this as a dashboard, as a monitoring tool, we can look and see what's happening. We can measure, looks like radiation, maybe pressure, things like that. And we can look at those measurements over time. And again, as an operator, I can use this information to make decisions and operate the system, right? So probably in cases like this, there's a detailed procedures that are written out, sometimes called run books. And looking at these different gauges, looking at those run books, we can make good decisions about how to operate this plant in a safe way. And finally, here's maybe a more modern dashboard. Maybe this is the kind of thing that you look at as part of your job. And just like these other things, these are charts that help you measure the health of your system, right? And here, health might mean something like, processes are not crashing, your users are not seeing errors, or it might mean your infrastructure is not overloaded. Just like the previous examples, you can use these charts along with your team's runbooks to follow planned procedures about what's happening. So great. So that's like part one. That's, again, really important. The second part is that of observability, I think, is understanding changes in that system health. And this is important. So first of all, I want to say observability is augmenting monitoring. All the monitoring that you have is still important. You still need to be able to do visualization, notification. You still need to be able to set objectives. But what observability, I think, brings to it, or maybe I'll talk a little bit more about this, but it allows us to understand change, both change that's happened in the past and maybe change that might happen in the future. And I guess I was thinking a little bit as I was kind of putting this talk together, like, do we really need a new word? Like, couldn't we just be like, hey, we've got to redefine monitoring? And I think, it wasn't up to me or anything like that. I'm not the only person talking about observability. I think the reason why folks felt like they needed a new word, why they had to import this word from control theory, was that something happened, right? Like there was some more sort of categorical change in, the way we build these systems, the way that we operate them, that meant that the old way of doing it was not enough. And the way that we're understanding those systems, the way that we're understanding change, also has to change in some significant ways. And so we need a new word to kind of mark that change in some way. So what happened? To do that, I got to talk a bit about software architectures. So I showed this picture before of how we might think about a system today. This is dramatically simplified. Even at Lightstep, we're not a huge organization, and we have, I think, 35 services and 6 databases or something like that now. I've seen people in the community and the industry that have hundreds or thousands of these services and storage systems. But if you go back 10 or 20 years, software looked pretty different, right? You didn't have an auth server and a checkout server and a GraphQL server or anything like that. You just had a client, and you had a business logic or an app server, and you had a database, and that was it, right? And so if you think about operating these systems, if you think about what you would do when something seems to be going wrong, if you're thinking about it in the context of, again, 2001 or maybe 2011, you had a runbook that you could follow, and you could use your dashboards to follow that runbook, right? So if we want to understand, we're getting maybe complaints from our users that something's broken. Let's look at the dashboard. Is the network down? Nope. Looks good. Any machines down? Nope. No, nothing there. Did we run out of memory? No, memory looks pretty good. Disks doing fine. Any crashes in the app server? Couple, but that doesn't seem like out of the ordinary. Database, no, that seems fine. With sockets seem a bit weird. Okay, now I need to know. I can follow the runbook. I know what configuration changes I need to make. Maybe I need to deploy a new instance or something like that. But I can use the runbook along with my dashboard to understand what's happened. Now, in this picture, really what I'm doing is I'm just kind of looking at all the failure points because we've built this kind of linear system. And so you can kind of just go up or down the stack, or I guess you can kind of come in from both ends if you want. But that's sort of how we understood failure in those systems. In 2021, things are a little bit different. So yeah, all these things can go wrong. But maybe the cache is overwhelmed, or that off service is crashing. Maybe someone made a bad schema change, that autoscaler always breaking. Problem with the reverse proxy, maybe S3 is down again. I don't know. Someone misconfigured something. Did anyone check the load? Is it balanced properly? This happens to me all the time. There's some fixed configuration. It's like says the payload can only be so big, and then eventually it's bigger than that. Maybe the app had a bad release and it's just behaving badly. The checkout team, again, always making bad pushes. Are we getting DOSed again on purpose? Maybe not. Maybe there was a hackathon. I don't know. Anyway, even if you build a dashboard that had every possible failure mode, it wouldn't account for all the possibilities. And don't get me started, there's often more than one factor here that's contributing, right? And so the idea that you can sort of linearly go through this list, this just doesn't make sense anymore, right? And this is actually a snapshot of a dashboard where something did happen. And you can see in each of these 8 graphs, there's some kind of deviation over on the right-hand side. But looking at the dashboard doesn't tell me which of those is the problem. It tells me that something's up with service health. I can certainly monitor that service health, but it doesn't help me understand that change. And I think stepping back, it's not just about me, right? It's about my team. And there's a real risk here, I think, that as someone new joins your team, they see this dashboard, they might think, well, someone smart put that dashboard together. There's probably a good reason for all of the things that are there. And it probably explains all the things that can go wrong. They understand the system and they just enumerated them. So if someone new joins your team, they see a failure and it's not explained by something on that dashboard, the risk here is that they'll actually think that it's not explainable, that it's cosmic rays or a network glitch or something like that, right? And that's a real risk because you want those new people to stay curious, both because the more experienced folks might not have thought of all the failure modes, but also because there's new failure modes being introduced all the time, right? These systems are changing, and so that dashboard's never going to be exhaustive, and besides for being probably way too big. So the way to think about this, I think, is really to focus on change. I like to think if it didn't change, don't fix it. And that's, I talked about software releases as one kind of change in config pushes and infrastructure updates. I mentioned, maybe you're trending on Hacker News and you're getting a bunch of new users, or again, maybe S3 is down. That's totally possible. All these things can contribute to failures, but these changes are happening all the time, and most of them don't matter. So the idea that you want to be monitoring all these changes as a human in the system is I think a total non-starter. And instead, I think the way to think about it is to try to understand which are the ones that are actually impacting your users, your business, your organization in some way, right? So is this something that users are complaining or might complain about, right? Is it something that's going to affect performance or the correctness of the software? Or maybe your users are not going to be able to tell at all, but when you get your AWS bill next month, you're definitely going to be able to tell that something changed. And really the trick here is that we want to be able to understand the mapping between these two sides, right? We want to understand how new releases might be affecting customer experience, how config pushes might be doing that as well. We want to understand how we can affect these causes, how we can understand how these causes can impact and can have effects that matter to our users and our businesses. So how do we connect those causes and effects? I've already shared some of the clues. One is we want to have the right raw materials. So it turns out the other reason I think why people talk about metrics, logs, and traces is they are actually really valuable kinds of data, right? Metrics let us quantify behavior. Logs capture important decision points and what the software is doing, right? It allows you to kind of reconstruct the logic of what's going on. And traces are also really important because they allow you to follow transactions throughout a system, right? So it's important to understand those interdependencies between those different services and then the dependencies there. And we want to take that data and we want to do some analyses with that data together. So it's not, again, just looking at a metrics dashboard and looking at a trace. I really want to be able to ask questions like, which version of service B is in the dependency chain of the slow transactions that originate from service A? Because that'll tell me maybe this version is something that's impacting that performance of service A. And this is exactly the question that you, in my hypothetical situation, are trying to answer. There's another really important question that you should be asking here too, which is, which version of service B is in the dependency chain of the fast transactions that originate from service A, right? So it's not just that they're in the slow, but they actually correlate strongly with the slow ones. And the thing here is there's like a lot of questions that we could be asking. It's not just service A and service B, it's C and D and E and F and all these other services. It's your cloud provider, it's your users, it's all those changes that I talked about before. So we really need those analyses to be performed in ways that are automatic and that are happening continuously and transparently in the background. Because there's not only is it hard for humans to answer these questions, it's hard for users to ask them, right? Like, I don't know all of my dependencies. My dependencies might have changed since I did a release because one of my dependencies changed their behavior in some way. So the idea that I as a human should be trying to track this, I think is not the right thing. And this is where I think observability is really bringing that value in terms of understanding that change. Okay, like I said, observability really has these two parts. One part that I think many of us are familiar with about monitoring system health. That's been around for a long, long time. And then a second part, which is really about understanding change. And I think, again, this is the reason why people talk about observability as something new, is that software systems have changed in a way that requires new ways of understanding that change. Okay, what's next? What can you take from this? So as you're thinking about monitoring and as you're thinking about observability, here's a couple things that you can go do. The first thing is make sure that you have the right data. OpenTelemetry, which you can check out at opentelemetry.io, is an open source project that helps you collect the right data from your application. That's metrics, logs, and traces. And it does that in a way that's vendor neutral. It works with a lot of different open source projects. It includes APIs for doing that, SDKs. It helps set semantic standards for how those data are tagged. It even includes components that help you start to build that data pipeline. It's a very cool project. I totally should check it out. The second part is having the right goals. I think I mentioned service level objectives and passing. If you have the right data, go Google SLOs if you don't know what those are. They're really, in a nutshell, SLOs are ways of just stating your customers' expectations and the commitments that you've made to your customers in ways that help you make decisions and do better planning and even do things like define the right alerts. And this really helps you narrow the space down of all of the changes that could be happening to the ones that really matter to your business. And the last piece, I like building tools. That's because I think they're important. And I think in this case, because of the complexities of the system, because of the number of different failure modes, the number of different kinds of changes that are involved, using automated analyses is really important. Like I said, humans cannot ask all the right questions, let alone answer them. And so we've got to use tools to do that. And that's exciting, right? There's a lot of good data. There's a lot of good techniques. I think data science, ML, AI is like only just starting to be applied in this area. And we're still learning a lot about how to do that in the right way. So a lot of interesting things are happening there. Okay, so we adopted DevOps so that we could scale our teams, so we could build faster. We changed our software architecture so those teams could work more independently, so they could make changes more quickly. But if we're going to do that and make sure that our systems are still reliable, we need to augment the way that we monitor our systems. We need to augment monitoring with ways of understanding changes, with connecting causes and effects. And that's what observability is to me. So with that, thanks everyone for hanging out. I know it's the end of the day. If you want to find me later, you can find me on Twitter at save_spoons. And yeah, I'm happy to talk about things and answer a few questions now.
Thank you very much, Spoons, for the presentation. I would like to encourage all to post some questions under the Q&A. We don't have any, although we would have one opening questions. If you work in a big company, how do you convince others that we should adopt observability?
So this is something I think about a lot, and there's like definitely some right and wrong ways, though like a lot of things, it depends. One approach that I've seen that doesn't work very well is to try and kind of find a place where it's easy to change tools. Often places where it's easy to change tools are places where it doesn't necessarily have a lot of value. And so I actually recommend that people kind of go the other direction and figure out where is the place where understanding change is going to have the biggest impact on your organization, on your users, and try to find that team and understand how to do it. From my experience, I worked on a team that was it was responsible for the back end of a web app console, but we actually depended on a lot of other services. And if I could go back in time and like pitch this to myself, the thing that would have really brought value there is that we were kind of caught in the middle between what users expected and what these other teams could provide. And we spent a lot of time basically just routing issues. We'd hear from users an issue, we'd try to figure out who was at fault, and we'd pass that on. Observability can automate a lot of that. And it might not have been easy to integrate there, but it would have been a lot of business value for our team in particular, and I think even for the organization as a whole.
Thanks a lot for your answer. Now we have a question from Bastian. Which kind of tools do you think we should use for analysis? Is it case by case, or why did you omit this?
I guess I omit it a little bit because I work on one, so I'm kind of biased. And my tool is not for everybody. I think the way that I would think about it is partly that tool is going to be based upon the sorts of the platform that you're working on, right? If you have 10 services, it's going to be different than if you have 1,000 services. If you're writing stuff that's still running in a Java app server, even if there's 10 of them, it's probably going to be different than if you're writing Rust and you're deployed on Kubernetes and things like that. I guess the way that I think of it, though, is that one thing I will say is I would definitely recommend against trying to build a new one from sort of off-the-shelf components. Liz Fong-Jones, who's a developer advocate at Honeycomb, has talked about this a bit too, and it's certainly something that Lightstep that we've experienced and seen other people experience, that if you just kind of pull, like a database off the shelf and pull a log aggregation tool off the shelf, the amount of data that you'll need to collect to actually do that analysis will be so big that it'll be really expensive or really painful to operate that database. And so thinking about a solution which actually is sort of end-to-end in the sense that it is collecting the data, it's processing it, storing it, and analyzing it is pretty important for observability use cases. And that, I guess, find me some time and I can tell you about like how we've built that at Lightstep. But I think, again, thinking maybe a little bit more specifically about your use cases can help you pick that tool. But again, thinking about it as an end-to-end solution.
Okay, I see no more questions. So we have one more. I heard service level objectives are something that SREs care about. So why should I?
SLOs I think are the new hot thing. I think maybe the simplest version is that if you look at the way people measure what's going on in software systems and measure like how well we're doing, they might start with something like MTTR, mean time to resolution, or mean time to response, or R can stand for a whole bunch of things. And that kind of, again, comes from a factory where we're thinking about like how long does it take to correct a failure within an assembly line or something like that. I think in software, things like MTTR are more like measures of the activity, like they're things on the inside of the organization. So maybe you want to look at that because that'll tell you whether or not, the people on your team are maybe I don't know, they have their phones next to them at night, or like they're paying attention to them. But your users don't actually care. Like your users don't care whether or not like someone woke up at 3 a.m. to fix something or not. They care whether it was broken. And so SLOs are kind of a reframing of things where we talk about what a user expects. So, and that, again, it depends. But they're, I think, pretty powerful because it's not just something that an SRE cares about or something that someone in a production that's working on a production system cares about. It's something that product managers should care about. It's something that engineering leadership should care about. It's something that customer support should care about. And so using them as kind of a bridge across your organization to sort of align on what's expected is actually a great way. And in a way, kind of back to DevOps definition number 2, like building trust and empathy within the organization.
That's cool. We have a few questions more. Another one from Bastian. Do you think observability makes sense for any team size? We are basically 2 devs teams in my project, and PM thinks shipping new features brings more value than adding monitoring. How would we go about it?
Yeah. I think I'm a technology person, right? But I talked a lot about people in this talk. And I guess at least at some point half the screen had people on it and half the screen had software in the form of boxes, I guess. So part of the way I think about this is like what does the organization look like with 2 teams? If it's not your fault, then you know whose fault it is. And so like you don't need quite the same level of tooling where maybe you have 10 teams or 100 teams. I think it is being at a startup like Lightstep, like this is a decision that we made over and over again, which is like where do we invest in new features and where do we invest in things like reliability or in tooling. I guess I would, if I'm talking to a PM, I'm going to try to phrase that in terms of like, well, we had this outage, or maybe like we're just spending a long time. Like when we're on call, there's a lot of toil, and we think, a week's worth of investment could actually reduce that in some way. And that'll actually let us ship more features in the long run, even if we have to do a little bit of investment in the short run. But I would tie it back to just maybe this is the same thing about SLOs, which is just like, are we meeting our users' expectations? Are we getting features out fast enough for them? Or, should we just hire more people because maybe that's the way to do it?
Someone else is elaborating the question. So should someone be delegated only for this purpose, depending on the team size? Because you already answered, but
yeah. So I feel like I'm going to keep saying it depends. It depends on how big the org is. I think in a smaller org, probably not. In the sense that like someone's not going to work full time on observability. I think you probably need a champion that will be able to make a case for why it's important and be able to, get buy-in from the right people. In larger organizations, I've totally seen, observability engineers, and their job is to help maintain this tooling, to make sure the data is flowing, to help educate people within the organization. I think, this is kind of the other reason why I tell people not to go build their own, is that even when you take an observability solution off the shelf, there's still a lot of work to do, especially in a big organization, to get it adopted and to make sure it's adopted in a standard way across all the different teams who, maybe themselves are using different tools and platforms and systems. And so there is work, I think, in a large organization as a kind of advocate and as the expert that can kind of bridge between what the organization needs and what this off-the-shelf solution can provide.
Okay, I think we have time for one more question. It's from Laszlo. Any example how a production issue was utilized in the development process?
So in terms of, if I'm understanding this, how do we use production issues in terms of thinking about like what new features or how we're building the systems? Okay, I guess I'll try and answer that. I guess I talked about a lot of this in terms of like responding to incidents. One of the things that we learned at Google was that this kind of data actually has a ton of other use cases besides just responding to incidents. It could do things like capacity planning. It could do things in terms of like planning optimizations. It could even help like the finance team understand how to plan for what they're going to need. But I mean, maybe to take a specific example around optimization, we used to have teams at Google that would go off and spend like a month doing optimization. And it turns out that it didn't matter because they weren't on the critical path. And so I think something like tracing and the kinds of trying to forecast change using observability, if I do this optimization, will it actually impact my users, is a really important question to ask, because otherwise, you could be on vacation or building new features or doing something fun instead.
Okay, I think we have 1 more minute for the last question. So Janos' question, I just read in. How we can be sure that we don't overdo the observability? Dev folks love playing such tools. How we can make sure we observe that variable and don't impact the performance of the team, even the system?
Yeah, certainly. It's the same. Impacting software performance is something that you should think about. You can measure. You should try to ask your solution to convince you that it's not going to be a thing. I think that maybe the harder question is like, how much do you invest, and how do you make sure that you don't overinvest? This kind of goes back to this tension of like releasing software quickly and responding to incidents quicker. I think I would motivate development teams in terms of the impact that they're having on users, and then look to see whether or not they're just being efficient in doing that. And their goal should still really be to release new software. Their goal shouldn't really ever be to deploy new observability or even to use observability, right? I think maybe a short version of this is like at Google, a lot of people didn't know that they were using observability, right? Like we just had put a link into a dashboard and they clicked on the link, and it turns out that they were using one of these analyses to answer questions. That's really the kind of ideal case fit. So maybe in this, I'm talking a little bit